So for problem number 36, it asks us to use interval notation to write the intervals over which the following functions are increasing, decreasing, or constant. So let's start with part A. What I'm going to do is I'm going to start by just marking the spots at which it seems like this graph changes directions. So I see a change in direction here, change in direction here, and one more here. So now looking at this, to the left of the first one that I marked right here, it seems to be increasing from negative infinity to -3. And then it starts decreasing, then it increases again from 0 to +3. So this is the interval on which, these are the intervals on which the graph is increasing. And I use parentheses for both sides because neither of the intervals actually contain the values. They share it with something else, or it's infinity. And also I have to remember the union. Now let's look at decreasing. So decreasing should be whatever is left, because there's no constant parts of this graph. So this is decreasing from -3 to 0 and from 3 to +infinity. Now for part B, I'm going to mark the points where I think it's changing direction again. So here, here, and here. So I see it decreasing, or let's start with increasing. I see increasing from -2 to 0 and from 2 to infinity. I see it decreasing from negative infinity to -2 and from 0 to 2. Then part C. Here we do have a section of the graph where it is constant. So we have, we have one change in direction here, and it changes to constant here. So let's again start with increasing. So it seems to be increasing from negative infinity to 0. Seems to be decreasing from 0 to 1, and it is constant from 1 to 4. It's only 1 to 4 because, as you can see, the graph stops right here at that hole. For problem 37, we have 3 different functions defined, and for part A, we're supposed to find f plus g of x. So for this one, I like to start by just rewriting the function as f of x plus g of x. Okay. So then once we have this, we can just add the two functions together. So we have x squared minus 5x plus 3 plus 2x minus 1. And this will simplify to be x squared minus 3x plus 2. For this next part, I'm just going to rewrite this as g of x minus f of x. And this is equal to 2x minus 1 minus x squared minus 5x plus 3. We have to be sure to distribute the negative sign here. So this is going to be equal to negative x squared, and then that would be plus 7x minus 4. Part C, this can be rewritten as f of x times g of x. And so this one, we have x squared minus 5x plus 3 times 2x minus 1. For this one, I'm going to show you work. So when we're multiplying a trinomial, which is f of x, just trinomial means it has 3 terms, by a binomial, something with 2 terms, what we're going to do is we're going to take the first term of the binomial, this, 2x, and multiply it all the way through the trinomial. So that's going to give us 2x cubed minus 10x squared plus 6x. And then we're going to do the same exact thing with the second term of that binomial, and we're going to add those results to what we just did. So that would be negative x squared plus 5x minus 3. Okay, and then we'll just combine like terms. So we're going to get 2x cubed minus 11x squared plus 11x minus 3. Okay, next we have g over h of x, and again, you'll see a pattern. I'm just going to keep rewriting these. With these problems, it's really helpful to just see an equivalent way that you can write it, just to make that notation easier. So here, we're just going to right away just plug in our functions, 2x minus 1 over 3 plus absolute value of 2x minus 1. And don't try to simplify this because there's no way to, okay? Next, let's do g plus h of negative 5. So here, it's going to be equal to g of 5 plus h, or that's g of negative 5, sorry, plus h of negative 5. And so g of negative 5 is going to be 2 times negative 5 minus 1, and then we're going to add 3 plus the absolute value of 2 times negative 5 minus 1. And so the first term here, this will simplify to be negative 11, and then this will be plus 3 plus the absolute value of negative 11. And the absolute value of negative 11 is positive 11. So we have negative 11 plus 3 plus 11. You'll see that the negative 11 and the positive 11 cancel out. So we'll leave us just with 3. Okay, lastly, we have f over g of 3. This is equal to f of 3 divided by g of 3. So this is equal to, let's see, 3 squared minus 5 times 3 plus 3. So you'll see I'm just taking 3 and plugging that in for all of the x's we see in f of x. And then over 2 times 3 minus 1. So I just did the same thing for g of x also. So this is equal to be 9 minus 15 plus 3 over 6 minus 1. And so that's going to be equal to negative 3 over 5. Okay, for number 38, we're going to find the difference quotient and simplify it for all of the following functions. And so for part A, we have f of x is equal to negative 3x plus 5. So we're going to say we have this difference quotient here where we have negative 3 of x, or times x plus h plus 5 minus negative 3x plus 5. This is all divided by h, and this is equal to negative 3x minus 3h plus 5 plus 3x minus 5 over h. You'll see a few terms will cancel here. This will leave us with negative 3h over h, which is just negative 3. Okay, next for part B, we have a different f of x, but we're just going to follow the same process again. So we'll have 2 times x plus h squared minus 5x plus h plus 3 minus 2x squared minus 5x plus 3. This is all divided by h. So here, we're just going to simplify after we expand. So we'll have 2 times x squared plus 2hx plus h squared minus 5x plus h plus 3 minus 2x squared plus 5x minus 3 all over h. I'm going to continue down here. So this is 2x squared plus 4hx plus 2h squared minus 5x minus 5h plus 3 and minus 2x squared plus 5x minus 3. So finally, after we've expanded this all out, we're able to start simplifying some things. So we'll see first we have this negative 5x, positive 5x, 3, and negative 3, and these 2x squareds will also cancel. So we'll be left with, let's see, we'll have 4hx plus 2h squared minus 5h, and that's all divided by h. This will simplify to be 4x plus 2h minus 5. So that h on the bottom will go away because all of the terms on the top and the bottom have an h included. Okay, lastly, we're going to find the difference quotient for f of x equals 3 over x plus 2. So the difference quotient is going to be 3 over x plus h plus 2 minus 3 over x plus 2. This is all divided by h. So here what we need to do is find and then multiply by the common denominator of those two fractions in the numerator. So the common denominator between, or what's going to be the common denominator for these is going to be x plus h plus 2 times x plus 2. So that's our least common denominator. And so what we're going to do is we're going to multiply this difference quotient by our least common denominator over the least common denominator. And we have to do this so that we're not actually changing the value of this expression. And so when we do that, we'll see that on the top, we'll have 3 times x plus 2 minus 3 times x plus h plus 2. And on the bottom, we will have h times x plus h plus 2 times x plus 2. And so now let's distribute those 3's on the top. So we'll have 3x plus 6 minus 3x minus 3h minus 6 divided by h over x plus h plus 2 times x plus 2. And this is equal to, we have some things cancel again. So we'll have negative 3h over h times x plus h plus 2 times x plus 2. And this h will cancel with this h. So our final answer for this difference quotient is going to be negative 3 over x plus h plus 2 times x plus 2. Okay, for problem 39, we're gonna find some composite functions. So like I was doing earlier, when we're presented with some notation that we don't really know, I like to rewrite it in a much more familiar way. So this g composite f of x, I'm just gonna rewrite this as g of f of x, like that, okay? And so this is going to be, wherever there is an x in g of x, I'm going to replace that with the entirety of f of x. So that's going to be like this, 2 times 3x squared minus 7x plus 2, close parentheses, plus 5. So this is equal to 6x squared minus 14x, and then plus 9, just combining like terms as I go. And then the last one, f of g of x, I'm just going to write this as f of g of x, like that. And so, again, wherever there is an x in f of x now, I'm going to replace that x with the entirety of g of x. So this is equal to 3 times 2x plus 5 squared minus 7 times 2x plus 5, and then plus 2. So I'm going to do some simplification here. First, I'm going to FOIL this. This is going to be 4x squared plus 20x plus 25, and then minus 7 times 2x plus 5 plus 2. And so this will be 12x squared plus 60x plus 75 minus, or not equals, minus 14x minus 35 plus 2. So combining like terms, I'll have this is equal to 12x squared, and then we'll have 60 minus 14, which is 46, so plus 46x, and then we will have 75 minus 35 plus 2. Let's see, and that will be 42, so that is our final answer.
All right. Well, now number 40, so it looks like we're going to be doing some compositions of functions. So A here, this means S composed of T, meaning that we're going to take T of X and we're going to plug it in for S of X. So let's go ahead and do that. So that means if we plug t here in for x in S, that means we're going to have 1 over x minus 10 minus 5. So now let's work to get a common denominator. So let's multiply this 5 by x minus 10 over x minus 10. Because then we're not changing the value at all, because we're essentially multiplying by 1. Okay, well then we'll have 1 over x minus 10 minus 5x minus 50 over x minus 10. And then we get 1 minus 5x plus 50 over x minus 10. And this simplifies just a little bit to negative 5x plus 51 over x minus 10. Okay, So there's our answer for part A. Part B, T composed of S, so we're going to do the other direction. I'm going to do it over here. So this time, instead of plugging T into S, we're going to plug S into T. So 1 over x minus 5 minus 10. Well, this is going to equal 1 over x minus 15. And it's as simple as that. There we go. That should be our answer for part B. All right, so now in 41, we're going to do this composition thing, but we're actually kind of going to do it backwards. So let's look at A. We're gonna try to pick two functions f and g such that the function they give us is a composition of them. So it's f composed of g. Well, here it looks like we have x minus 7 plugged in under a cubed root. So what we could say here, oops, is that f of x can be cubed root of x, and g of x can be x minus 7. Well, then we can check our answer, just plug in g of x for x and f of x, and then we get A there. So we're good. How about B? Well, it looks like we have 2x plus 5 plugged in for x squared, so we can pick that. X squared, g of x equals 2x plus 5. Again, you can check your answer by plugging g in there to f, and then you'll get there. So next is part C. So we have 4 over x minus 2 quantity cubed. With some of these, there's multiple ways you can do it, but let's just talk about them for this one. Here you could say f of x is 4 over x, say, and g of x is x minus 2 quantity cubed. Or you could also say that f of x is 4 over x cubed and g of x is x minus 2. There's more than one way to skin a cat, so there's a couple ways you can do some of these, but these are acceptable answers. All right, so 42. At a popular website, cost download individual songs, $1.49 per song. In addition, a first-time visitor to the website has a coupon for $1 off that they get to use one time. So how do we represent the cost for a first-time visitor to purchase X songs? Well, it's $1.49 per song, right? So 1.49x. But then you take away $1, right? Minus 1. So here would be our function. Okay, sales tax for online purchases depends on the location of the business and customer. If the sales tax rate on purchase is 6%, write a function to represent the cost for a first-time visitor who buys $80 in songs. That sounds really confusing, but I would note that our variable this time is actually A, the dollars. Whoops. Our variable is A, dollars, not number of songs this time. So sales tax is 6%, so if sales tax is 6%, this means you pay full price and then 6% more, right? Well, this would just be 1.06 times A then. That would be our function. Now I'll find T composed of C and interpret the meaning in context. So this means we're going to take T, we're going to plug in C. So let's do that, just like the earlier problems. Okay, so we have 1.06, but instead of A, we're going to plug in our function that we got for C. Excuse me. Okay, so there we go. Now, what's the meaning? Well, you could say that what this means is that X means how many songs you buy, right? And this is really just the amount of songs you buy is as a function of the amount of songs you buy. This part right here, like we did earlier, represents how much it costs. But then this, on the outside, everything represents the sales tax on it. So what this really means is just the after-tax price to buy X songs. Maybe you should also note, since the coupon is for a first-time visitor, this is the after-tax amount you will pay to purchase X songs as a first-time visitor. Okay, now D. Let's find T composed of C of 10 and interpret the meaning. So we'll just plug in 10. So 1.06, 1.49 times 10 minus 1. So then this equals 14, in here, 1.06 times 14.9 minus 1, 1.06 times 13.9. This is 14.734. But since this is an amount in dollars, we'll have to round away this. So we'll say $14.73. Okay, meaning and context. Well, this means if you buy 10 songs as a first-time visitor, then you're going to be paying $14.73. Nice. All right, for 43, we're given a quadratic function, and we got to tell them all this information about it. So first, whether the graph opens up or down. Well, if you look at this 2 here, you can see the sign on it is positive. So that tells us this graph should open up. So we'll just say up. Now the vertex. Well, that's not so bad. This is in vertex form. Remember, vertex form is saying that in here, the coordinates for our vertex are going to be x minus h squared. Let me put the a out front here, but whoops. I'm writing this as an inconvenient spot. Okay, I'll write vertex form over here. So vertex is like this, squared plus k, where the vertex is hk. Well, in there's x minus -5, right? Because that's how you would get positive. And then minus 8 at the end, plus -8. So that's our vertex. All right, the y-intercept. Well, the y-intercept is where the x-coordinate is going to be 0, because at that point it's going to cross the x-axis. So, sorry, cross the y-axis. So let's plug in 0 for x. And what do we get? We'll get, I'll write it over here. 2 times 0 plus 5 squared minus 8 equals 42. So y-intercept then is 0, 42. X-intercept, well, now we'll plug in 0 for y. Because 0 equals 2 x plus 5 squared minus 8. So do some algebra here. Move the 8 over and then divide by 2. So 4 equals x plus 5 squared. So then x plus 5, if we take the square root, would be plus or minus 2. Because if you think about the shape of a parabola, we'll have 2 x-intercepts. Like here's just a general parabola. So in this one, since it's in this shape, we'll have 2 x-intercepts. And you can get that if you take the square root, because remember, square root is positive or negative. So then if we move over to the 5 to both of our cases, so x plus 5 equals 2, or x plus 5 equals -2. So if we move the 5 over, we'll have x equals -3, and x equals -7. -3, 0, -7, 0. Okay. Minimum or maximum value of the function. Well, that sounds like the vertex. We know the vertex is -5, -8. So, and since it's opening up, that means our vertex, if you look over to the left here at this parabola, our vertex is going to be a minimum like this. Well, we plug in -5 and we get back -8, so minimum value, -8. Axis of symmetry. Well, this is actually kind of, if you look back at this little sketch I made on the left, this is kind of this line here, which passes through the vertex. So we just want that vertical line, which would be an x-coordinate, while the x-coordinate of the vertex is -5. So there's our x's. Okay, domain. Think about what x values can you plug into this function. Are there any x values that don't work? There's actually not. You can plug in anything. And if you graph it, you might also be able to see that the domain just extends forever. There's no holes or anything. Now what about the range? Well, we just said that the minimum value is -8, right? So that would be in our range. Whoops. -8, okay. And then there's no maximum value, right? It just keeps on going up, so infinity. Be sure to put that square bracket next to -8, because that one is included. All right, so here we're going to do what we had just done on that previous one with listing all the information, but it looks like first we're actually going to have to complete the square to put it in vertex form. So I know completing the square is scary, but hopefully this will make it not so bad. So let's look at A first. So the first thing I notice if I'm going to complete the square is that I see this 6 here in the middle. So you might know we would divide that middle number by 2, right? And that gives us 3. So 2 equals 3. And then we want this to look like a perfect square trinomial, which would be like this, right? This here would be your x plus 3 squared, because that's 6 divided by 2. Well, if we work out x plus 3 squared, right, this gives us x squared plus 6x plus 9. And you'll notice what's different is here we have 9, here we have 5. So how do we adjust this right here? How do we adjust this so that we have plus 5 instead of plus 9? Well, we can actually just take away 4. Well, since x plus 3 squared equals x squared plus 6x plus 9, if we take away 4 from both sides, equals x squared plus 6x plus 5. And hey, that's what we were completing the square of. Oh, whoops, I forgot to write the -4 over here. -4. There we go. Okay, so here we are. This is it. I'm about to underline in blue. That's completing the square for part A. So now let's find the information. Right? Okay. So this is in vertex form. So firstly, opens up, because we have a positive out front. It's not negative. Determine the minimum or maximum value. So what's the vertex? Oh, we need to find the vertex, that's right. Well, it's in vertex form, so talked about before, since it's x minus the x coordinate, that would be -3, and plus the y coordinate, so plus -4. So there's our vertex. The minimum or maximum value. Well, since it opens up, the vertex would have to be a minimum value. Again, draw the sketch. Here's a parabola that opens up. Well, here's the vertex right here. It's a minimum. Okay, so let's just keep going. So that there would be our vertex. And we said our vertex is a minimum, so minimum value would be -4, the y value or function value there. And write the domain in interval notation. Well, this is a polynomial or parabola, right? So it's actually has an unrestricted domain. Whoops. Oh. Can't seem to write there. Can't seem to work an iPad either. So domain. Infinity. There we go. Okay, let's do the same for B. So for B, I'm going to write it here under what we did on A. So for b, first thing I notice is you can actually factor out -2 here, so I think that's a good plan. So we have -2x squared minus 10x plus 4 equals -2 x squared plus 5 minus 2. Okay, now we can do our completing the square procedure. So if we go ahead and do that, well, we want 5/2, right? So if we divide again, we would get 5/2. So 5/2. So now let's write our thing with the perfect square. So x plus 5/2 squared. Well, what does this equal? This would be x squared plus 5 plus 25/4. Well, we don't want plus 25/4. We want this to be -2. So how much would we have to subtract? Well, x squared plus 5 plus 25/4. So first, I guess we could subtract 25/4, and then subtract 2 more. So all in all, we would be subtracting 25/4 minus 2 is 8/4, so minus 33/4. Right? So minus 33/4 is everything that we took away. So we know we can write this part here on the left that I'm going to underline here. We can write that as our perfect square. This leaves x plus 5/2 quantity squared minus 33/4. Okay. So we have to remember the -2 we factored out though. So stick a -2 in front of everything. And if we distribute, we get -2 x plus 5/2 squared plus 33/2. So there we go, we're in vertex form. Okay, so then does it open up or down? Well, it's negative on the outside, so we'd say it opens down. And what would the vertex be? Well, if we remember vertex form again, it's minus the x-coordinate inside there, so -5/2. And then a plus the y-coordinate, so 33/2 is the vertex. And is it minimum or maximum? Well, it opens down this time, right? I'm going to sketch another parabola here. So our vertex there would be a maximum. Max equals 33/2, because we want the y value. So we have the vertex, it opens down, and the maximum, and now we need the domain. Well, it should once again be -infinity to infinity. There's nothing in here that you can't plug in. No x value that just doesn't work. Okay, next one, last one for this time. I'm going to just erase some of my work over here so that I can make some room. Let's get rid of some of this. I don't know why it's not erasing. That's okay. Let's just do it over here. So 3x squared minus 8x. So on this one, well, we got to factor out a 3 because we want just plain x, right? So factor it out. 3x squared minus 8/3x. All right. Well, now this number here, we would divide by 2. Oops. Divide -8/3 by 2. Well, then we would get over 3 times 1/2, -8/6. Okay, so we would have 3, and then well, let's worry about the 3 later. So this looks a lot like x minus 8 over 6 quantity squared. Because then what would that give us? That would give us x squared minus 8 over 3 plus 64 over 36. So we would just need to take away 64 over 36 here, which I think that simplifies just a little bit. Let's see. Should simplify down to 16 over 9, I think. 8 over 3 plus 16 over 9. Okay, well, we need to adjust this to get just 3x, or x squared minus 8 over 3x. We want to adjust it to get this thing right here. So we'd have to take away this 16 over 9. Let's do that. So then we have x minus 8 over 6 squared minus 16 over 9. Well, now we can remember our 3. Everything gets multiplied by 3, so 3 x minus 8 over 6 quantity squared minus 16 over 3. And nice, we are now in vertex form. We can simplify that 8 over 6 also to 4 over 3, so write 3 x minus 4 over 3 squared minus 16 over 3. Okay, this one opens up, right? Because we have positive 3. And what's the vertex? Well, remember x minus negative, so it's minus 4 over 3. And then minus 16 over 3 on the outside, so that's our y-coordinate. So then our maximum value, I'll just write it out up here. Maximum or minimum? Well, it opens up, so it's got to have a minimum. And it would be the function value there, which was negative 16 over 3. Then we want the domain. And domain should again be negative infinity to infinity. Okay. Right, so now we're using the vertex formula to find the vertex of these. So you might remember the vertex is, the x-coordinate of the vertex is negative b over 2a. Well, b is 6, so here we have negative 6 over 2a. Well, that's 2, so that's negative 3. So that's the x-coordinate, so let's plug that in. Then we get negative 3 squared is 9. Negative 3 times 6 minus 18 plus 5. And then this should be negative 9 plus 5, so negative 4. So this would mean our vertex here, let me do some erasing, should be negative 3, negative 4. What we're doing is finding the x value, then just plug it in. So let's do the same thing here. So on part B, we have negative b would be 9, right? I'm going to write it out over here. Negative b would be 9 over 2a, which would be over 2 times negative 3 is negative 6. So that should simplify, I think, to negative 3 over 2. Then we can plug that in. For the sake of space, I think I'm going to do it over here on the bottom right. Spaces. Something I'm quickly running out of. So we get negative 3 times negative 3 over 2 squared minus 9 negative 3 over 2 plus 8. Okay, this should be negative 3 times 9 over 4 plus 9 times 3 is 27 over 2 plus 8. Should be negative 27 over 4 plus 27 over 2 should be 54 over 4 plus 8, which is 8 times 4 is 32, so 32 over 4. So all this ends up being 59 over 4. So that's our y value, basically. We found the x value and the y value. Negative 3 over 2, 59 over 4. Nice. Okay. So let's do this last one. So negative b over 2a. Well, there's actually nothing in front of an x term on c here. We just have 6x squared minus 5, so this means b is going to be 0. So negative b over 2a would be 0 over something, which is just going to be 0, right? Maybe we could say 0 over 12, which is 0. So our x-coordinate is 0, so now let's plug it in. So 6 times 0 squared minus 5, well, that's 0 minus 5, so minus 5. 0, negative 5. So there we go. Okay, 46. Rocket is shot straight upward from ground level with an initial speed of 98 meters per second. And the model is this equation representing the height of the rocket, s, at t seconds. So find when the rocket will reach its maximum height. Well, that should happen at the vertex. So we could do exactly what we were doing with the vertex formula. So negative b over 2a, so negative 98 over 2 times negative 4.9. Well, you can put that in our calculator here. That gives us 10. So this is like the x value or the t value in this equation. So it will reach its maximum height at 10 seconds after launch. So then, to find out when where the maximum height is, well, we just plug in 10. So 4.9 or negative 4.9 times 10 squared plus 98 times 10. And we can just plug that in our calculator again. That gives us 490. So maximum height should be 490 meters. Okay. Final question.